There we go. Yeah, so we'll do an overview of LCA and then dig into the demonstrations. And if anybody has comments, questions, or something you want to chime in, I mean, we've done a handful of LCAs. I know a lot of, or some of the people in this call probably have as well. So if you have comments, best practices you want to chime in and share, feel free to do so. We've done LCAs, but we're not the, we know we don't know the whole picture. So feel free to chime in. So yeah, like I said, for the agenda, a bit of background about LCA. So a quick overview, what are some industry efforts? What do we mean by system level reductions versus material level reductions? We'll look at 2 case studies, talk about some of the limitations of LCA and LEED, and then we'll get into the demos and share some resources with y'all. So what is LCA? What does it look like in rating systems? What are EPDs? I'll scan through the embodied carbon stuff pretty quick because I know we've gone over this material before, but super quick. When we're talking about an LCA, we're talking about emissions from the materials themselves. Not to say that operational carbon isn't important, but that's talking about lighting, heating, and whatnot. But we're looking at the building materials, so a lot of it is just quantity takeoffs and then assigning a value to an environmental impact value to those quantities to then have your report. When we look at the timeline of these emissions throughout the lifespan of a building, there's all the embodied emissions are up front. So most of what we're looking at is in this practical completion section. So it's all up front, and then the operational emissions happen over the lifespan of a building. And the reason that's relevant is particularly when we're looking at new construction. When we're looking at new construction and we're considering goals by 2030 and by 2050, that upfront chunk, it becomes a lot bigger piece of the pie. So it's something like, I think 75% of emissions from new construction are from the materials between now and 2030, and about 50% between now and 2050. And it's significant because we're building a whole lot. A lot of this is urbanization in the global south, but even here we're building a lot. And so one of the highly touted reduction strategies is let's just not build at all. Let's reuse a building and use kind of existing material with carbon that we've already spent. But that's not viable everywhere. And what I want to emphasize with this slide is this really is a global effort. It's important for us to be sharing our best practices. We're not operating in a silo. There's a lot of new building coming in the next couple decades. And so embodied carbon, or carbon, is often used as just kind of a shorthand to mean the greenhouse gas emissions or global warming potential. But when you're doing an LCA, you're looking at all these different impact categories. So when we talk about carbon, that's the global warming potential, and it's widely considered to be the most important because it's driving climate change, but it's not to say that it's all that's important. There are other environmental factors, and one of the reasons you do an LCA is to be considering all of these alongside one another. When we look at where these impacts are coming from in a typical building, the majority is coming from the structure, a good chunk from the enclosure, and then MEP, and then kind of all the interiors and whatnot. But when you do an LCA, one of the reasons you're doing it is sort of to understand how am I going to, you get a sense for where the emissions are coming from in your building, and then you use that to inform a reduction strategy. And so understanding where the impacts are coming from it's like, okay, we need to look at the structure. We need to understand where this is coming from. And that it's like, okay, let's pay attention to the floors. Let's pay attention to the foundation. So that's how but this is kind of the rough breakdown. Tom, you want to take it from here?
Yeah, sure. We could sort of fly through these, but just on life cycle assessment, obviously the environmental effects, any given activity, initial gathering of raw material from the earth to the point all residuals are returned to the earth. Yeah, so it's sort of a soup to nuts from extraction to sort of the end of life of a product. And I guess when we sort of talk about whole building LCA, we're talking about that sort of at the building scale. So everything that's gone into it until the end of life, with possible recycling capabilities that we'll talk a little bit about. We can move on, Martine. Yeah, again, these are relatively quick, but just looking at everything that can be involved in a full LCA, obviously pretty extensive. But again, I just a case eminent slide, I think, from material extraction all the way through to disposal, with the possibility of recycling some of those materials and what the impact is in those 7 categories that Martine mentioned is sort of what we're looking at in LCAs and certainly in whole building LCAs. I think the next slide is right. So this gets into a little bit of the modules, which I'm not sort of a modules expert, and Martine probably knows more about this than I do, but obviously it's good to sort of remember the big ones that you have sort of A in the creation essentially of, if you're looking at a building, it's in the creation of the building, B is in the use, C is in the disposal, and then I think D is sort of how you could sort of tweak the knobs, if you will, based on what you're using in the building that can be recycled and how that contribution could sort of kick back in to your overall LCA numbers. And I think the next one, right, method. LCA is the method, EPD is a report. And this is just to say, and Martine, you can correct me if I'm wrong, but obviously an LCA is not necessarily an EPD. An EPD is sort of the verification of a portion of an LCA that's done on a product. So, a lot of times we think about if we're going to look at building LCAs, well, we got a lot of this information on the impacts of some of these products because a product LCA was done and then the EPD or the report was actually published about that LCA for the impact categories. And then that kind of fuels into this idea of a full building LCA.
Yeah, and we'll talk about this a bit later as well, but when we think about the system reductions, so whole building reductions versus material reductions, EPD is just for a material. It's just saying for the concrete mix, or even an industry average saying for in this area for 4K site concrete, this is roughly what you're looking at for impacts. But it reports those. And then when we think about the different modules, most of the impact is coming from is coming from module A, the sort of processing manufacturing, and EPD only lives in module A. Kind of the assumptions for use and maintenance and repair and then end of life is captured in an LCA, but that's not usually reported by an EPD.
Right. So you'll in tally will identify a ceiling tile, and the impact of that ceiling tile will come from an LCA that was done sort of on their module A essentially, and the EPD that came from it. So we'll know from essentially cradle to when it gets to the construction site what the impacts have been of that thing in your building, whatever that is. And these tools or Athena and Tally and others kind of can help amass those and give you an idea. So then you can actually run an LCA sort of on your whole building. And I think we mentioned like the nutrition label on the next one, right? Exactly. So, and again, not to confuse with the HPD or the health product declaration or some of the other things. When we say you sort of throw around this nutrition label thing, but it's essentially saying, and especially for those EPDs, say this ceiling tile, the environmental impacts in those categories from creating this thing in module A and bringing it to you are as follows. And that's essentially what that EPD is showing you. And that's why sort of requesting them and the push through LEED and other methods is important, because we're trying to bring that transparency into the industry to say, hey, what were the environmental impacts of making this thing that we're about to put in our building? And sort of asking for that is helpful. Right, yeah, and I think there are a couple more on this. Obviously the LCA overview, and we're going to sort of do this to some extent, just sort of quickly, and Athena and Tally, but obviously the goal and scope are important, and we'll talk a little bit about those. Construction, size, scale, all these things matter in sort of end of life scenarios and how you consider that. The tools to use, we'll show you 2 viable tools today. Project goals, which is something else that we can talk a little bit about. I'm no expert at sort of conveying all these things to owners and what the goals should be. And we rarely have owners that are sort of setting specific goals and reductions, but I think slowly we'll get there. And right now I know we use the LEED sort of reductions of baseline building versus sort of your building, you know, but what exactly does that mean? And we push a lot of that onto structural and some of their work that they can help us with, but we'll talk a little bit about that. And then the reports certainly will show in these two examples sort of what the outputs of doing the LCAs are. And this is it. This is a great sort of EC3 diagram where we're looking at material quantity estimates on the left, which is something that Tally and Athena can do. And certainly Tally, I'm familiar with. One of the big powerful things is that it does this for you. It sort of looks at your model, takes all of these things out. It's saying all these materials, what are their quantities multiplied by the impact. So usually EPDs or other LCAs that have been run, what's the impact of that steel beam? Okay, it's X, Y, and Z. Okay, I have 100 steel beams. That equals a portion of your building impact estimate. You sort of add all that up, and that's where your whole building LCA comes from.
Now we're going to talk about industry efforts. Tom, do you want to go over Architecture 2030? You don't need to.
I can. You might know a little bit better on the embodied side what they're doing currently, because I know there's some different flavors. I definitely, you know, Page is signatory to Architecture 2030, which is I believe it's the 100% removal of fossil fuel energy in your buildings by 2030, and every year, every whatever, 5 years, I think they have different reductions from a 2003 database. So 2003 was a while ago, so it's not that hard to beat those benchmarks. But I think we're up to like a 80% or 75% reduction from those benchmarks in operational use, which is a challenge. Hence the name of the Architecture 2030 Challenge. So we're reporting on that right now, and that's operational. On the embodied side, actually, Martin, you might know better than I. There's a push for that as well through Architecture 2030 now, mm-hmm. Right?
Yeah, so it's sort of parallel to the other goals that they're setting, because you can see here on the left, it's pretty comprehensive. So it's not just looking at carbon. There's also energy usage, water usage, transportation emissions, and it's, I mean, being that it's Architecture 2030, it is geared towards architects. Not to say that that's the only people that it's affecting. But yeah, recently, especially in the last couple of years, as embodied carbon has become a bigger part of the conversation. They started to include, so you can see the goals that they're setting. So they're saying immediate, and then when they announced it in 2018, they said let's immediately get 40% reductions, then 40% reductions by 2020, then 45 by 2025, and 65% by 2030. But in addition to Architecture 2030, the one that's more specific to kind of the structural engineers' response to this is SE 2050. And what SE 2050 is, it's setting similar goals. It's focused on structural engineers, and it's specifically focused on embodied carbon. So it's a bit more targeted than Architecture 2030. But essentially what it is it's sort of a commitment program saying let's get to zero by 2050. But it's not just asking for firms to kind of make a loose promise. Basically what it does is there's a whole commitment process where once you get involved with the program, there are a couple of deliverables. If you need to come up with an embodied carbon action plan, you need to start reporting the information. And then, so as SE 2050 is working with these different organizations, it's supporting action and offering resources, but then also collecting the data that they're reporting. Because one of the really tricky things, and it's important to keep in mind when doing an LCA, is LCAs are really valuable for informing directional change. So you can use the numbers to say there's a lot of impact in my floors, I'm going to reduce the impact in my floors. What it's not as good at is getting an absolute value. So it's not good at saying, I know exactly how much carbon went into the atmosphere because of this building. And the reason for that is there are a lot of, we don't need to go into the details, but there are a lot of assumptions that are made between softwares. Like we're looking at Tally and Athena today. If you run a building in Tally and then you run a building in Athena, you can get pretty different answers. That's not to say they're not still useful, but the best way I've heard it put is every model is wrong, but that doesn't mean they're not useful. And so it can still inform that directional change. But what SE 2050 is trying to do is start to collect these material quantities, because like we mentioned earlier, you have your material quantities and you have your impact values. But SE 2050 collects impacts and collects material quantities and wants to set benchmarks, because it's really hard to say how much carbon is supposed to go in a building, because there are so many variables, from geography to typology to building material to all sorts of different stuff. So given the complexity of that, SE 2050 wants to start kind of whittling away at that and getting a better idea of what's a reasonable like embodied carbon per square foot that we might be able to say for different buildings. So those are kind of industry efforts. One of the, I mean, we talk about motivations for doing an LCA. How do we convince owners to care about this? One of the main drivers is often lead points. There you can get, I guess, up to 4 points in lead. And I think, is Dirk on the call? Because he was the one who med the change from, or
I am. Martin, you're doing a good job. Do you want?
I was just going to say, like,
background?
the change that you see here, for, like, including the getting you points for just doing an LCA. I just wanted to give you credit for that change.
Oh, well, thanks.
So yeah, so the way that it works in Lead V 4.1 is just doing an LCA, not making any reductions, just looking at the materials in your building and getting the impact numbers. You get a point, and then you get a point for 5% reduction in 3 out of the 6 categories, and 3 points for 10% with 3 out of the 6 categories, including global warming potential or carbon. And then the fourth point is if you get 20% reduction GWP, and then you also include salvaged materials. And if as LCA grows, these ideas continue to develop, and we continue to understand, well, what are the valuable strategies? What should we be rewarding people with? And so these things are always changing and updating. And so I'll say specifically about Austin Energy Green Buildings rating system. So it currently has a very similar mechanism to LEED, but we're in the process of updating it to give even more benefit to doing an LCA and to getting these reductions, and it's more robust in how it includes EPDs. So these things are moving, and these things are constantly changing as we have a better understanding. But needless to say, LEED is a common motivation for wanting to do an LCA at all. So system versus material reductions. So what we mean by that is basically talking about a system level reduction. If we look at a whole building, if we use less material, that's a system level reduction. For material reductions, if we have the same building, but then we have lower carbon materials, that's a material reduction. And the reason it's important to have both of these and to be tracking both of them is if I have a building that I put really low carbon materials in, but is really materially inefficient, I'm able to get my LEED points. I'm able to get that 10% reduction, but I use a lot more material than I might have otherwise if I had been a bit smarter. And so that's why all these different things running in parallel, thinking about the embodied carbon per square foot, understanding that value, so the effort that SE 2050 is having, alongside the importance of EPDs of getting the lower carbon values, and then alongside doing an LCA and understanding the whole building. So different strategies you can have at different points in the process. So right at the start, if you don't build anything, that is a great way to reduce embodied carbon, because then there's no embodied carbon. But beyond that, of course, there's reusing a building. If a building exists and there's already that material, then use it, take advantage of it, and refurbish that material and use existing buildings. And the reason for that is because the embodied carbon has already been spent. It's already up there. When we look at that graph, the embodied carbon's there from before the doors open. So if you've already built it, let's take advantage of that. But then, of course, beyond that, reduce and replace materials and structure. So try to cut down on how much material you're actually putting into it, and then reuse as much as you can products and materials again. And some of this can get into a kind of a bigger conversation about design for disassembly. That's different. We're not going to go down that path, but not to say it's not important to consider. And then, of course, require low carbon products. So once we have finally, or after we do our material reductions, after everything, like, okay, well, with what we have, let's make sure it's as low carbon as possible. And so just super quick view of what do a couple of different high impact materials look like. So concrete, it's all about cement. It's not just about fly ash content. Like percent SCM replacement is a good way to get lower cement, but what's lower cement matters. If you have a 500 pounds per cubic yard of cement, and then you have another mix that's 500 pounds of cubic yard of cement, but it has some fly ash, it might have higher SCM replacement, but it's going to have very similar impacts. The cement content's what's driving that. And there are different ways of getting there. So the SCM replacement is one way, but there's also, be more intentional about your cure times. There's CO2 injection from stuff like carbon cure. But at the end of the day, what's most important for these things is getting an EPD and just like kind of having the proof is in the pudding and making sure that you get those numbers. Because if we just slap on these kind of greenwashed ideas, then it's not necessarily as effective as actually showing the numbers. And when we use those numbers and put them into different databases like EC3, we can then use it on more of an industry level to understand what should these materials be looking like in different regions. For steel, electric arc furnace produces kind of wide flange and hot rolled members. Basic oxygen furnace produces HSSs. And it's a lot more, it requires virgin ore. You can use more recycled steel, or like 99% recycled steel with an electric arc furnace. So in the US, we do a better job of this. I think it's something like a 2/3, 1/3 split. We use more electric arc furnace. I think it's flipped globally. But yeah, so understanding where the steel is coming from, specifying wide flange over HSS. And for wood is a whole nother complicated conversation, but what it comes down to, especially for designers, is leveraging sustainable certifications like FSC. And so making sure that you're specifying all our wood needs to come from, it needs to be FSC certified. And so we've got some secondary materials, looking at, so insulation, staying away from high intensity HFC blowing agents. So look at material like wood, straw, clay, hemp, cork, sheep's wool. So those like naturally sequester carbon. The blown in fiberglass and cellulose insulation have much lower embodied carbon than some like rigid insulation or spray foams. Gypsum, a lot of the extra impacts from gypsum are just because there's wasted material. So using lightweight gypsum and eliminating waste as much as you can. For envelope, lower window to wall ratios, reduce your aluminum use. If you are using aluminum, prioritize recycled aluminum. And for carpet usually only is a significant contributor on like a refurbished project. And I'll say there's a lot more information about these different materials if you go to Carbon Smart materials palette. Just Google that and we'll provide a link. But it has a really nice breakdown and a lot more information about these different materials and what the different strategies are and why they're effective. Okay, case studies. So I'll start with the first case study. So it's Austin FC here for a new MLS team, and it's so we had
You have to be quiet.
Sorry, I'm gonna. So it was kind of a two-pronged approach. So one of them was system level reductions, and then we also still have material reductions. So the basic structure was has the precast seating and then concrete elements, concrete foundation, and then a steel roof. And when we did our preliminary LCA, so this is broken down by material, you can see the two big contributors are concrete and metals or steel. And that's kind of unsurprising because we know there's a lot of concrete, we know there's a lot of steel. But the point of that is one of the, in lieu of EPDs, so this, there aren't currently concrete EPDs being produced in Austin. So in lieu of EPDs, our approach is generally, let's put a maximum cement content and let's let that be informed by the NRMCA regional average. The National Ready Mix Concrete Association has average cement contents and cement impacts broken out around the US. And so we use that as a benchmark and then understand, okay, I think we can achieve below this. And then we put that in our specifications. But from this preliminary LCA, we understood that's not going to be enough to get us the lead points that we want. And so when we look at how this manifests in design documents, we have our sort of classes of concrete matrix, and you can see all these different concrete usages, but then we specify a maximum cement content. And so we say you can't put any more cement because we know that's the main driver of what's happening in the mix. And so that's how we can effectively achieve our reductions without an EPD. Not to say it's not better to have an EPD. It is absolutely better to have an EPD and to have a performance-based specification. And you can see some of that here. So when we look at like GWP acidification, so that's setting a maximum performance-based standard. If we can't get those values, cement is what's driving it. So we go off cement. But in addition to the concrete changes, what we did, there was, so it's more common, especially in the US, for these kind of long span stadium roofs to have a planar truss. And for this one, we used a cable system, and it's less common here because it's a different erection sequence, and it's just not the standard of practice, but it's not totally unreasonable. And one of the things I'll highlight there is functional equivalence, and having a reasonable baseline. And it's because when we're doing an LCA, we have a baseline that we're working against. And so it basically has to be, is it the same size, shape, function, environmental performance, or thermal performance, sorry. And is it reasonable? Like I can't compare my building to just a big concrete block. And so understanding that, it is perfectly reasonable to have expected this to be a planar truss, but we went in something else instead in order to get these tonnage reductions. That's why it was effective in the context of the LCA. And so when we look at what happened over time, so each of these are each different impact categories, and they're each changing over time. So the first one, that was just the baseline building. And then the second one shows from the reductions we got just from the steel. And then the third is the first concrete submittals we got. And then as we were working through the project, we basically had kind of this like, well, we need to use a higher cement mix. We need to use something different here. And so we had to work with them, and we were continuing to rerun the LCA. And this is something that's not terribly hard to do within these softwares. But as we get new information, we said, okay, we assumed it was going to be 420 PCY, so it's actually going to be 450. We worked with them on those reductions, and then this is what they ended up with. So our number 5 is what they ended up with. And then number 6 is, well, if we had updated a different mix and put in a different spot, that's what we could have done. So when we look at the 10% reduction, we could have got that in 3 places for that extra point. But then, and what actually happened is we didn't get that point. So it was a bit of a trade-off, and in the whole context of the LEAP project, it was okay. But this is where we're digging into these tools and sort of playing around with different inputs.
Yeah, Martine, I'll jump in. You had multiple good, that's also great. When you work with a structural engineer who wants to do these things, it's also very helpful to see you work through some of these. Sometimes it's a little easier said than done, I guess, on some of these things. But another case study, you had some really good ones, and I think we thought that obviously the stadium would be kind of fun, and you had some more sort of structural ones, which I think is very important for architects. But also I wanted to show a couple examples. Actually, they're not even ones that I've done. I've done some similar stuff to this, but just looking at the cladding and something that could be more architectural. This is a McLennan design, just a screenshot that I pulled, essentially looking at, it's wall 1 versus wall 2. And this is global warming potential, I guess, or embodied carbon. They're just looking at the kg CO2 equivalents. But in running sort of a wall, and I can't remember, so they have XBS insulation, and it looks like they made a couple other slightly different choices on the sort of left side wall. Yeah, it looks like they have a standard gyp board and then sort of a lower carbon gyp board. I know there's some eco gyp products out there now, but essentially it's saying that we looked at wall 1 and we did an analysis. And again, it's using LCAs or these EPDs, and sort of they're adding up to give you the global warming potential of one wall construction, and then what reductions you've made, and then looking at wall 2. And again, the cladding is not going to be as much as sort of changes in steel, and sometimes, the concrete, if you're using a lot of it. But it's something that architects can directly affect in their design process, and you don't really need any coordination. You just kind of go through it and decide you want these products, and these are better products, and you're looking at EPDs, and you're trying to essentially change your cladding, which, like I said, is something that generally you have a lot of power over, that you can sort of make those changes. So they have a 22% reduction. And I think my next example is something similar. Yeah, this is LMN. So not surprising, LMN is a great firm and has been doing some of this work. I think this diagram is actually pretty old now, but they have a baseline wall condition, a precast wall with thin brick, and they sort of look at these possible wall conditions throughout. So brick over insulated metal panels, brick on metal studs, and I guess various, I don't know, they have bad insulation and mineral wool, and they might be playing with sort of the insulations, but you'll see the drop, 2% down to sort of 25%, and then getting down to around a 40% drop when they looked at thin brick on metal studs. So again, Martina, I think you made a good point. I don't think these things are necessarily exact all the time, but there are good relative studies, and it's nice to see just from a purely architectural standpoint, not structural, saying. Now, of course, thin brick and et cetera has structural ramifications in using that versus precast thin brick. But if you as an architect have control over, the wall assembly, it's studies like these that I wanted to pull up and sort of show to everyone that have been done and can be done to really show that, and if this is your common wall and you're using this all over and it's a 6-story office building and however many 100,000 square feet, you can make a pretty significant reduction if you make these types of choices, or at least go through the process of saying, okay, we're looking at this wall. Give me 2 other constructions that are generally in the same budget that have a better global warming potential than the wall we've proposed. Go forth, project architects, and come back with answers. And this is the kind of stuff that you can do.
Yeah, so a couple of limitations about this whole process. We've mentioned some of them. And I mean, one of the points that I want to make is as many limitations as there might be and as imperfect as the process is, we don't have time to get it perfect before we roll this stuff out. We kind of need to start taking action as quick as we can. And so as these processes get better, well, let's workshop them, let's understand them, let's learn them, and then let's kind of everybody grow together. So the idea of, well, I don't want to do an LCA if it's not even giving me an accurate carbon number. Well, you can still use it as an effective tool. So looking at, absolute versus relative differences, we're not really getting absolute differences, but we can still use it to inform the right directional change. Benchmarks for whole building LCA, like understanding in a hospital in Austin, Texas, it should have this much carbon per square foot. We don't really have those numbers. But I mean, not to say we're not working on them. So as we, like, if once we get those numbers, maybe we can use them. But as we get there, like, contribute projects to SE 2050. Talk to your structural engineers about getting on SE 2050 and sharing that data, and get more people doing LCAs so we can have more informed conversations. Differences in scope with EPDs and impact data. And so like I said about between Athena and Tally, you can run the same building through both of them and get really different numbers. And sometimes comparing different materials can get a bit fudged, and it's not perfect, but again, it's still important to engage in the process. It's easy to get away with bad practice. I mean, these processes aren't perfect. Everybody checking lead LCAs isn't going through each and every line and making sure your building's perfect. Stuff isn't always modeled correctly in Revit. It's not perfect, but I mean, it's important to keep these things in mind as you go through the process. Understand the limitations and make sure you can still use it effectively. And uncertainty isn't being captured. Like we have, because we kind of have these industry averages. Where's the uncertainty? What do we know about the transportation? What do we know about where these materials are coming from? And especially for something like an industry average, if that is coming from a bell curve, why aren't we seeing it as a bell curve? And yeah, so I mean, those are some of the current limitations, but there are still things we can do. So what do we need to do here? Local, not just locally, but everywhere. Reuse existing buildings. That's a huge way to reduce embodied carbon. Do LCAs. One of the reasons that in LEED and in AEGB, you get points for just doing an LCA is you can't reduce what you're not measuring. And so many people in the building industry aren't even measuring. So let's take the first step, make that more standard practice, and then we can start having we can have better conversations about how to model, how to perfect the process of LCA, what should we be checking, but we got to do it first. And even short of doing LCAs, talking about just material quantity tracking. If I'm not gonna do the whole LCA, But I can at least have a good sense for what I'm putting into the building. And so starting to incorporate that in your modeling practices of, well, this is a different concrete mix, so maybe I should model it differently in Revit. Ideas like that is the direction that the industry is going. And so it's hugely helpful for these industry efforts. And then requesting EPDs, especially for concrete, especially in Austin. Because if every mix has an EPD, then we have a really good idea or we have a much better idea of what does concrete look like in a particular municipality or particular region. And that connects to sort of broad policy efforts like Buy Clean, that's sort of leveraging government procurement to require EPDs for certain materials, but at least ask about it. There's no harm in saying, like, either give me an EPD or tell me why you can't, because it's really easy to say why you can't, but you're at least starting the conversation, and then they understand that there is user demand. Contributing to the circular economy, so design for deconstruction, reusing materials, and anything that's reducing material use is effective. And then of course, leveraging policies, leveraging incentives, and that's speaking more broadly, but a lot of that starts with how much power lies with the designers. And so what can the designers do? It's like, well, start the conversation, ask for low carbon materials, ask for EPDs. And yeah, I want to highlight the graph just to say, like, California is kind of running with this. I think I saw Luke in the chat, he's in LA, but Texas isn't even on here. We don't have any EPDs, and they have 23,000, or probably more than that, because I think that graphic's from a couple weeks ago. But with that, does anybody, so that's kind of the background. We can go right into the demonstrations unless anybody has any particular questions. I've seen some people chatting. But if there's nothing, then Tom, do you want to take it away?
Yeah, sure. I can do that. I'm just going to share my whole screen. Right, so, and I saw in the chat, Luke, you had mentioned that Payette tool, the kaleidoscope, which is a great tool. When I go there, I have to temper my jealousy because Payette is great and does a lot of great work. So that tool is also kind of a cool, fun thing to get quick ideas about different facade types and cladding and some of their impacts. So I'm sharing this fun little model. So this will be Tally, and I'm just going to do a walkthrough. As said, my previous disclaimer still holds true. I use Tally a lot. There are certain buttons I probably never pressed. So if anyone has, feel free to jump in. And Martin, you can check out that chat and see if anybody has any questions, wants to yell at me. So I have two models, just sort of a dummy model that I created. And then let me see if on this other model, right. So more of like a built out full on kind of full comparison / lead model that I've done recently for a project. I think this project is public or something. I don't know. Anyway, but for the first one that I'll go through, just very simple, we'll get some of the basics of Tally. And then, like I said, the second one is more just show and tell. We can look at some of the results. As far as model setup, again, having been in Revit for so long and feeling like I understand what it wants, which is kind of scary sometimes. I don't know if that's a good thing, but Tally's pretty turnkey. Once you install it, it essentially just pops up in your add-ins. And that's kind of it. Then you really just press the button and it walks you through the process. I think the only big question for me that comes up a lot is sort of to detach or not to detach, which is often the question. And again, it's I think about it with like daylighting analysis. It kind of depends on where you are in the process. I like to detach if I'm going to do big whole building LCAs because I must have constant control of everything. So if I'm going to do a whole building LCA, I will pull the architectural model, and usually I will pull the structural model, and I will bind in the structural model, and I will then just hammer it. I'll just go through material by material, and we'll talk about this as well. the whole point essentially of Tally is to sort of say, okay, here's my stuff. Here are the materials and the quantities that are in my model. And Tally has this big database on the back end. And the point of Tally is to essentially make those connections and say, okay, yes, I have 5 steel beams in my model. And here's what it is in the Tally database. We'll make that connection and then do that sort of full multiplication that we talked about previously. So
Kendall mentioned work sets as well, which I think you're going to go over.
Right, which we can, Kendall's sort of beaten me to it. We can, let me see, sorry. So on the full model that I did, Kendall, I do very different, I do sort of multiple work sets on some of these larger things. And we'll talk a little bit about how you could sort of chop up these models, but that is a very good point. Again, if you're doing a really big model, like this one is this is a concrete frame versus a steel frame comparison, and I built these models separately. This is totally detached. And because I'm going to work with work sets and I'm going to pull stuff away and I'm going to take, just because I'm like this, I'm going to put all the toilets on a hide work set. I'm going to just clean all the work sets out to just get to what I'm looking at, which, for instance, if it's LEED compliance, we want cladding, we want the floors, we want the structure. So I'm going to work those into work sets in the ways that kind of make me happy. And dare I say it, if I am detached, there are times if I don't like something, I'm just going to delete it and get it out and bye-bye forever, which I try not to do, and I try to work through work sets. But sometimes life is life, and I don't need the furniture for landscape. Not saying that it is important for carbon, it might be, but we're not looking at that. So that might just have to go bye-bye. The trees are going to go bye-bye, et cetera, that sort of stuff. So there are a lot of ways to chop that up. But again, the detach or not to detach for me is really kind of that first big question for model setup. If it's a small thing, if it's early design, if it's a quick study between 2 things in the model, and you're not going to get confused on what material is what, you don't have to detach. Just run it through a production model. It's easy. Tally's pretty non-invasive. If it's going to be a big model and you're going to change a lot of material names so that you can keep it all straight, I would definitely detach for that. So, let me just open this little dummy model. And essentially when I hit Tally, this is the first screen that comes up. And we'll talk about at least 2 of these full building and design option comparison in this model. This does have some design options. Define template file. I don't know. Don't quiz me. I don't use it that often. If anyone really knows, we'll have it out and we can talk about it. I think it's if you're running a lot of the same material mappings over and over again, you can actually set up templates. So when you open models, I think it might do some of the mapping for you, maybe, but feel free to jump in when we get to that. But full building study is usually what I start with. And to Kendall's point, you can define what categories in the Revit model you want to analyze. And again, usually if it's sort of LEED compliance, we're lobbing off things like doors and stairs and railings. But if you're trying to do a full-on whole building comparison, you want to check all these. In this model, I don't have a lot of stairs and railings or any at all, so I'm going to check everything. I'll look at the main works that I'm working on, new construction, and the phase demolished is none. And these are sort of required that you put in. And I should say full building study and Tally just means it's going to look at everything in the model, but it's if you only have certain things in the model, it's only going to pick out those materials. So you can do sort of quick analysis, or you can do a full building study, but only check ceilings, and it'll pick out all the ceilings. And even then, you only have to map certain ones that you care about or that you're looking at. So it's kind of how you define that scope. And so this is a little bit pre-baked. This model, I have already done some of these mappings. And again, I keep saying mappings, essentially saying this is what's in my model. I'm going to connect it to what's in the backend database for Tally. So I think I did floors, walls, windows, some of these things. So let me clear the definition of the cast in place floor quickly and just walk you through how I go about this. So Tally has run our model and they've pulled out all the floor objects in the model, and they're saying, okay, you have a floor type that's cast in place 8-inch, and here's that material. It's concrete cast in place gray. but I don't know what that means in tally, right? We have a lot of different flavors of concrete, so I can't map just concrete onto your deal. You have to tell me what kind of concrete it is and that sort of thing. And we'll get into this a little bit, but you can have a lot of different types of concrete in a project. So if the architectural model just has concrete everywhere, you then have to start to go in and select all the piles and say, these are 4,000 PSI concrete. So you might change that material in the model. And that's when I talk about detaching, whereas the slab might be 3,500 PSI concrete. And so you might change that material in the model so that then you can identify it through tally more easily so that your model has some more specificity in the materials that get mapped to tally. So there's a lot of talking. It's not going to take all that long, but I do want to show you concrete because it's a big one. So when you edit that definition, now you're going into the tally database. You've sort of crossed over from what's in your model to what is in the back end database in tally. And it filters through, and you can essentially select from div 3 through 9. And it is sort of searchable. So if you put in concrete, it's going to bring up all the places where concrete comes up in their database. So this is cast in place, and it allows you to choose default PSIs for concrete or a cast in place custom mix. And again, if it's just high level architecture stuff, you might not get into this just yet, but I do know, obviously, with concrete being a big emitter and looking at global warming potential and looking at a lot of lead comparisons, it becomes very important. So I did at least want to show it. I won't walk through everything, but when you hit apply, now Tally's saying, okay, cool, custom mix of concrete, but we have so many flavors. We got a lot of choices on that. So now you need to define, again, that CIP concrete in your model. Well, what does it actually mean for Tally so that we can put an accurate assessment of the environmental impact. So I won't go through all this. This is just to show that you can do a cast in place custom mix. You can pick your Portland cement. You can go, it's going to go by volume, and you can specify the percentage by volume of the entire mix, or your kilograms per square meter of cement within that mix. So you can go down the line and pick through all these. Obviously, we won't do that. We can go more simply and just say, I don't know, it's 4,000 PSI. It's a slab. I don't know. Martine, Dirk, they're probably, I don't know. Am I right? Is that close enough? 4,000 is good, right?
Yeah, I mean, so when you're, and so go ahead and click on 4,000.
Yeah.
Because when we do, looking at like the Austin FC, so we did that one in Tally, and now Tally includes the NRMCA regional averages, right, which is great.
Yeah.
But we had kind of our generic mix that we put in with custom.
Right.
And the reason it was custom was because these NRMCA mixes weren't in, because we said we're in the South Central region and we want 4 KSI as our baseline. So we had to put that in as a custom mix, but now that it's baked into Tally, you can use your regional average from NRMCA, which is really helpful.
Right.
And I'll just speak out. Those regional averages are incredibly important when it gets to comparative LCAs if we want to best model what we're actually getting. And I think Kendall makes a plug about talking to your structural engineer, which I would second.
For sure. Yeah, absolutely. If it's early on and you're sort of pre those conversations, you can do some of these, but obviously for more informed analysis down the line, you definitely want to obviously work with the structural engineer. And like I said, the second model that I'll show you, kind of the fully baked one, we got drawings from structural. It was actually a schematic thing, but we got some very basic drawings from them, but with PSIs, with things worked out. And Dirk, that's a really good point. Now that these averages, so again, that's the regional average of what your concrete makeup usually is. Aggregates, fly ash. In some places you have less fly ash than other places, just because that's what the industry is. And some of those things, there's more slag in this part of the country and that part of the country. And if you're doing a lead comparison and you're saying, here's my building and here's the baseline building, they want you in the baseline building to use these averages for your concrete, because I think in sort of olden times of the credit, you would say, well, we're going to do 25% fly ash in our slabs and the baseline is no fly ash. But that's not exactly correct, right? Because the baseline is going to be based on one of these regional averages. So we'll just select that. And then, and again, the further questions that Tally wants to know, sort of going from your model that's very general, CIP 8-inch concrete, down to what it actually is, so Tally can analyze it for you, is asking about reinforcement, which is not something that we, usually mess with as architects. And I'll say straight up, I usually am running with either, a moderate reinforcement in a lot of these slabs. Again, I don't know, Martine might be cringing, but again, especially true, as we said, if it's a comparative analysis and you're looking at two things, if you're keeping those things consistent as you go along, you can still sort of understand those things. You don't want to say, unless you know for a fact and you've spoken with structural and they're saying, yes, we're doing low reinforcement here and we are changing it for these reasons, then you can do that. But usually I just keep it easy, go with moderate reinforcement, which will go by volume and will give you a default that they do. So
yeah, and
lots of talking.
I'll just add, like, if you do know exactly how much rebar and you really want to include the exact amount of rebar,
Okay.
I mean, to Tom's point, if it's staying the same, what's the point of changing it if it's not a huge contributor? But you can just kind of add blobs in Revit, and you can say like, all right, this is my rebar blob, and so on my concrete, I'm not going to put any rebar, but over here, this is where I'm going to put it. You can still define the material.
Yeah, and I should say that too, like. If you look at these cool buildings, but the truth is, like, this roof could be anywhere in the model. Like, I could just throw stuff in there. Like, I don't have to build a building. It's just going to look at the materials and pull those out. So anyway, so that is essentially what you do. Again, I know that was a lot of talking, but it is that mapping that is really the key to sort of showing Tally what your Revit model is. It analyzes it, and then you really drill down to what things are. So I'm going to go through a couple more examples, and then we'll get into the results. When you hit the Save Report button, what comes out? So again, this is just a dummy model that I put together with the roof and some walls of different types. We'll talk design options too very quickly. It's very similar to this. So Tally is pretty good at looking at these sections and sort of saying, okay, we've picked up on something that you have named plywood sheathing. There's this much of it, total wall area, perimeter. They'll look at the thickness of it for you, and then you get to map that to their sort of list of sheathings that they've put together with EPDs and LCAs. I wanted to call out the stud layers because this is kind of interesting. This is an exterior wall, and we've named this metal stud layer, but this is a 6-inch metal stud layer. We have an interior wall that has a 3 5/8 inch, I think, metal stud. I think that's what I put in. The issue, and I've run into this sort of on purpose, is that these are named the same material in my Revit model. So Tally is picking up on them as the same thing. Now you can define them separately and they won't be the same thing, but after you define one, it's going to say, oh, hey, Tom, we see this metal stud layer in 10 other places in the model. Do you want to say that it's the same thing? And sometimes the answer to that's yes, and sometimes it's no. So I'm going to sort of combine things. Let me edit this definition and show you, again, how to do that mapping just for a little bit more practice. And then I'll show you kind of how this gets a little odd that you want to watch out for in Tally. So again, with the filter, I'm just going to do stud, and we'll say it's, we'll call it framing with insulation. Sure, it's an exterior wall. We'll say that it has, I don't know, 6.5 inches of bat in there or something like that. Again, this can be different depending. These are Clark Dietrich Pro Stud EPDs, which means that they have the EPD that they've brought in. They probably use some industry-wide for cold form structural or galvanized or the like. So we'll just do their studs. The takeoff method, again, a reason that I wanted to bring up studs because it's very common in projects. I'll do by length for some of these. I don't necessarily do by volume because I believe Tally is sort of looking at this as all one thing and sort of saying, here's an area, and you know that it's studs. So you actually want to sort of define, you can do spacing, right? What kind of studs and what kind of spacing. And that is probably like the best, easiest choice to make, right? Because you know what the studs are, you know what the spacing is. You don't want to confuse Tally by thinking that it's solid and I don't want to get into like volume percentages of what the volume of the wall is or stuff like that. So, and again, Tally has made improvements over the time since I've been using it. So maybe it knows how to do all that. But again, because I desire full control at all times, I like to define exactly what the walls are. So it's a 6-inch stud, a 20 gauge. We'll say it's one way with perimeter, and we'll say it's 16 inches on center. That's going to define that wall. Insulation type, again, it has various EPDs, and then other, I think that it's probably taking some kind of industry-wide or something like that. So we'll just say it's blanket, it's unfaced. We'll go volume on that because you can generally imagine the whole cavity is filled with that. And we'll save it. So that was to sort of show another example of how that mapping works, right? It found this material called metal stud layer, and now we've told Tally what it is, but this is what I was talking about. Tally is sort of saying, okay, hey, Tom, we found this metal stud layer material somewhere else in this other wall that you have, interior wall. We found the same thing. Do you want to apply it and make it the same thing or not? In this case, we don't, right? Because we defined 6-inch studs. This is a 3 5/8 inch for an internal wall, so we skip it. And you'll see now it's mapped that metal stud layer, but it has not mapped this metal stud layer. So if we edit that definition, this one would be the same. We would go into stud, and we would just say that it's metal framing, and I don't even really have to go through it with it, but you know, we would do the 3 5/8 inch at 16 inch on center, and we would map that as well. The last one I wanted to show is another similar mapping that we've done, and I've done these already for everything else. So on the roof, I looked at shingles, I edited the definition, they have asphalt shingles. I looked at sheathing, if you edit the definition, I just put OSB, you know, whatever, I'm just sort of picking things to show. For gyp, you'll see this is the interior side of that exterior wall. We do the mapping here, relatively easy. We'll do wallboard and gypsum. It brings it up in div 9. It'll say, what's the board type? I don't know. Let's always give it type X. So this is another small thing. Again, you can go by volume, which is probably fine in this case because that 3 5/8 inch gyp is probably modeled correctly, or it might be. If it isn't, or if you are not convinced that it is, you can also go by area. And if you go by area, it's going to ask you, sorry, I keep saying 3 5/8 inch, you know what I mean, between the stud and the gyp, but you'd say it's 3/8 of an inch, or, you know, maybe it's a 1/4 inch sort of thin gyp, whatever it is. So that's Tally's way of letting you say, okay, some stuff might not be modeled correctly, so you can go by volume if it is, or you can go by area and then specify for that wall type that thickness. So I'm doing that. Finish, we'll say it has an interior latex. It's not foil facing. And
hey,
we'll
Tom, are
that.
you covering service life at some point?
Yeah, I can. Yeah. Yeah.
You were on that screen and there was one thought that, didn't, if you're doing it later, that's fine. It just can get tricky sometimes.
Well, I should say, no, Dirk, please, by all means, go ahead, because if it's talking about the materials themselves, usually I just sort of run that through the default.
If you go, so go back to your input, and I'll point out what I think we might even be able to point this out. So just one of the things that we have found that we just want to be mindful of. So Tom did a great job showing how you put things in. Exactly. This service life toggle will have, what it does is it counts how many times it needs to be replaced. And for structure and structure, it's usually the life of the building. But for these enclosure assemblies, one of the wonky things that can happen is as you layer them, if you use the defaults may not necessarily all be the same. Like they may be things that are stuck together, and there's no way you could physically replace something inside of something else at 20 years if you're replacing the outside at 30 years. So you want to make sure that you're accurately comparing that. And for things like roofing, you do want to do that because over the 60 years of the building, you might need 3 of one type or 2 of another. So just
so the shingles might get replaced.
Yeah,
but the layer in between 2 layers that won't be replaced is not going to be replaced, even if you say that it is, right? Because they're not going to pull it apart like that.
Exactly. You want to make sure there's a common sense lens to just kind of think about as it's built up.
Exactly. And I appreciate that, Dirk, because I am an anarchist and I very rarely change that stuff. I'm just like, cool, let's do the default, let's roll with it. And that's important because as we'll look at the results, and again, I will go quickly as we jump into the results, and I'll just show you a little bit of what the outputs are. They do have that in the module of saying, you know, in the operational life, there's a blip of embodied carbon output because we're assuming that in 30 years, we're going to replace X, Y, and Z. And I think you're defining what that X, Y, and Z is. So you're sort of controlling what that blip is going to be during the renovation cycle about halfway through this 60-year building. Is kind of what I'm thinking they're getting at with that.
Exactly. Yep.
Yeah. Right. Okay, great. So we'll save that. And right. I just wanted to mention again, similar but different from that, from looking at the studs. This is your wallboard gypsum, and it's saying, hey, Tom, okay, cool. We want to make this easy for you. We found this same material name in a bunch of other walls on your project. Do you want to take this definition and attach it to those, yes or no? We didn't do it in the studs because, again, we have different sizes of studs, and we wanted to identify them separately per wall. Here, because we're going to assume, yeah, you're going to paint the inside here on that wall the same as there's another little interior wall in there the same. It's going to be the same gyp, type X. I'm going to apply it. And so now you'll see that it's defined that gypsum wallboard on that interior. So it's going to look at both those and give it the same thickness. And I did quarterage, so that's probably wrong, but you know what I mean. It's going to give it the same thickness for both of those throughout. So that's how tally works. That's the tally of my world. And this is a relatively easy one. If we go to a bigger one, which I will, you can see that it is, it can be a very long, arduous process to do a whole building life cycle analysis this way, but it is cool. And when you finish it and it shows you stuff, you're like, wow, this is amazing that all this stuff came out of it. I did want to quickly, if I should also say, we can get into a bunch of stuff. If you change stuff in the model and hit refresh, it will pick it up. So if you're saying, oh, darn, I should call that stud layer 6-inch stud. So it'll show me the difference between the one stud that's just regular, you know, and then the 6-inch. If you make that change in the model and refresh tally, it looks at your model again and will pick up any changes that you've made. So I should say that as well. Quickly, I put a design option in this, is just playing with metal walls. I think I have a brick, as you can see, and then jump down to a metal panel wall. Okay, sure, cool, whatever. That's my other model, sorry. You can analyze both of these, and you can do a design option comparison. If you do the full whole building model like we just did, it only looks at the main model. So whatever your primary is what it's going to look at. If you look at the design option, it's going to do the same analysis. It's just going to pull up those walls. We've already defined that brick wall in the main model. We already did that. And I don't know why windows are in here. Sorry, y'all. The windows are the same in both, you know. And again, Windows is asking you can look at the glass, you can look at the system around it. Once you get into Tally, it starts to make a little more sense how they do Windows systems. But you'll see that the metal panel is not defined, because that's new, right? This is the second of our design options. And I'm not going to go through all this, but you could just see the layers that it's analyzing. And you would, again, you know, I don't know, what do they got? They have air barriers. We'll say that this is a self-adhering. You'll hit apply. It'll give you 40 mil, which is sort of their typical, and you can save that, and then you have your air infiltration barrier. You do this for everything, and then you kind of hit go, and it'll give you a report that compares those two things. So that's it for just kind of how Tally, I think, works and how I usually work in Tally. Again, Martine, if there are any questions coming through,
go back to the Tally window. Did you do the isolate and Revit view? So if you...
Oh no, I did not. That's a good question. So yeah. you can isolate stuff in Revit, which can be very helpful. And actually, let me, and it essentially, it turns on your sunglasses, so you can sort of reset it. I guess there's no reason we can stay in the design options. Sure, I was just going to go back to the main one. Yeah, but if you're looking at something and you don't know where it is and it's upsetting you because you're trying to figure it out, it will let you select that. This might be being a little weird because it's in design options. Yeah, it is very helpful.
Which is do full building. A lot bigger projects.
Yeah, exactly. Right. That's the point. On really big projects, you know, you'll have 8 different types of HSS and on, and you're like, where are these? And are they even in the model, or did I forget them out in the yard somewhere? You can definitely drill down and sort of grab those, and it'll show you. And then that's helpful too, because then you can go in and you can get it and you can edit the type. And design options. So if something's wrong, if you're noticing something wrong in Tally, you can go in and you can edit it, and you can, you know, if you wanted to rename this plywood sheathing Tally 1, just to remind myself, oh, that's the roof plywood sheathing Tally 1, which is different from the sheathing somewhere else is Tally 2, and I found that by doing the hide isolate. That's great. Then actually, I believe if you refresh, is it going to show it to me? Did it not? Right. So it's still mapped on there, but it picks up that the new thing that you just did. And then if you change stuff like too drastically in a certain way, it'll say, hey, wait a minute, you broke the mapping, come back. It's now yellow, and you have to change it. So, like I said, that's kind of Tally in my world. Very quickly, this is a larger, these are schematic models, but the client wanted to see the difference between a steel structure and a concrete structure. We're sort of often asked this question. So in defining scope, to Kendall's point here, this is the workset view, so you can easily see what's on what workset. I did everything in the concrete frame and concrete enclosure separately versus the steel frame and steel enclosure. And I did that because when I do that, if I pull these up, they all should be mapped. It's going to look at those. And Martina, I want to give you plenty of time, so I only want to go for a couple more minutes. But everything's been mapped here, and there's a lot of stuff in these models. But you'll see the curtain wall mullions, the floors. You'll see that I've changed the name of some of these, I hope. Right. So you'll see in these, I have a foundations cast in place as a material, so that I'm going to change that PSI, like this is going to be mapped. Well, you can see it here. Tally will tell you that's mapped to 5,000 PSI. The footings are mapped to 4,000 PSI, right? And that's because those materials are different. And when Tally picks them up, it says, hey, they're different material names. Where do you want me to match them? You know, how should I make those connections? Oh yeah, this is a big one, right? So structural footings, a bunch of different materials mapped to different types and families. Once you do all of this, so this is a metal panel, and we went through and we added the definitions and we put, you know, we made all the mappings to this whole thing, and then you can sort of save the report from this. And I'm actually surprisingly following what I said I was going to talk about. So once you're ready to go and you're like, okay, this is all the stuff I want to analyze. I want to do my concrete frame and my concrete, like the cladding attached to my concrete structure, my version of that in this design option. I've defined that scope. When you go through, you write down everything you want. Gross building area, expected building life, I think defaults to 60. It does want you to fill all this stuff in. You can include construction impacts, which I never do because I don't know what they are, but you can. And I believe this is actual impacts in construction of resources used to put your building together. I usually don't do it. Also really cool operational energy impacts. And again, you know, Tally is sort of made with the help of a lot of software people, and then Karen Timberlake, some of the driver, they sort of is a firm out in Philly where the drivers for Tally. And I just named that to say it's very cool because they actually let you put in an EUI, kBT per square foot. So I know architects a lot of times talk in EUI. So if you're at the end of the project and you kind of know that there's an office building, and we'll give it a 75. And I think there was a comment in the chat that we're supposed to be 90% better than Architecture 2030, 90% better than CBEX 2003. So really this EUI ought to be more like, I don't know, like 35 or something, maybe even lower than that for this office building. But you could put that in, and then you can find, guess what you could find? Good old ERCOT. You can get good old ERCOT, our favorite sub-regional grid mix. And when you run the report, it will actually, if you're all electric, let's say, it'll put operational in there, and it'll show you like, here's all your embodied, here's operational. And it's really helpful because it really can show you those diagrams, you know, on sort of a world scale of where embodied is going to operational. It kind of gives you your own version of that. The output summaries, what comes out of the Excel and the PDF, and I'll show you those in a second for these. You know, I usually leave all those checked. I don't usually edit transportation at all, but you can. So if you know these are averages, if you know that the kilometer of your brick is coming from here, or again, you know, structural concrete, 25 miles or well, 25 kilometers, whatever it is, it's because they're mixing it relatively close and bringing it to you. You can't change these. I usually don't, but you can. You know, you can make your concrete come on a container ship if you really want to, like, you know, bump up those kilometers. So that's usually what I do, and then include and exclude biogenic carbon. we could have a whole talk on biogenic carbon, but I usually include it. I think that you know, that sequestration. I also don't ever. I'm never lucky enough to work on the CLT, the mass timber project. So it's usually not a problem for me. I'm usually just trying to convince clients not to build everything out of concrete, every single thing out of concrete. So anyway, so I have some results just to show you what came out. So in this model, because of the work sets, I ran cladding, I ran a concrete frame, I ran a steel frame. So the steel frame is just going to be all of the foundations and steel and the structural, and then we'll put cladding on top. It's just an additive. But what comes out is two documents. They will give you a PDF with some cool, fun pictures on it, and then they'll give you what I usually end up using is the Excel sheet, and the Excel sheet will tell you back to that LCA. We finally come full circle of the 7 categories, plus I guess the sum of mass total. It will show you an estimate for whatever you inputted for your building for what these things are. Obviously, global warming potential being a big one that we look at often in comparison, but it will give you information, et cetera. Everything that is, you know, relatively correct and what they think based on your mappings, your building is going to output. You can go by modules, by stage. It'll pull it out by division, category in Revit. So again, it's very tied to Revit. Divisions, tile entry, divisions material is a big one. So you can see sort of where your materials are. Obviously, some global warming potential in concrete here, because we still, even though this I think is the steel model, we're still using the same concrete frame. Although I think the foundations might have got a little smaller in this model. But and then the other output is the PDF. Which gives you similar overviews, right? Just in kind of a fun, cool tally report. I honestly don't use these all that often. Like I said, I go into the Excel and pull the numbers apart, but you could see itemized by division, for instance, what percentage each of these works on a division. And you can see obviously your concrete and your metals. This is only the structure. So obviously those are going to be pretty heavy, but similar to some of the tabs in the spreadsheet, it will give you graphics. And then the last thing I'll show is the other thing that I like to do, and I do a lot of, is I actually pull up, I just pull all that stuff out. I will copy this stuff straight up out and drop it into another spreadsheet. So here, I just pulled the steel structure, the concrete structure, and the cladding together. And you can actually look at some of those mass totals and kind of what those differences are. And then I do comparisons, steel structure plus cladding, concrete structure plus cladding. We do the dreaded kilograms CO2 equivalent to try to get to pounds per square foot to try to get a carbon intensity. And then I usually end up with, we have structure only 70 versus about 100 pounds per square foot of CO2 intensity for these projects. So that's my tally world, all day, every day.
One more, can you go back to the report?
Yeah, sure.
The PDF, and then just scroll to the bottom. Like
oh
towards
yeah.
the bottom.
Oh, the fine print. Oh yeah.
The fine print. I just wanted to, like, if you're curious about where the LCI data or where that's coming from, go down a bit more.
Mm-hmm. Yeah.
It should show you for everything in the building. It says, you keep going.
Oh yeah. It talks about the modules, and then it gets down to stuff like this. Is this what you mean? Like,
yeah, but it should show it by material.
It goes by material somewhere. Concrete, scope.
Oh, there we go. Yeah. So like fire. So it shows you like
about.
Coated steel deck. This is what it's doing. This is where it's coming from. This is kind of like a full description of the material. So if you're really curious, like, so you can see the EPD source. So if you're really curious, like, where is this data coming from? It's in the fine print. And not like you don't usually have to dig in that deep, but the information's there if you need it.
Yeah. Right.
And that's a good place to see that service life too. You see the 60 years. If you, to kind of sanity check it as you're flipping through.
Yep. Mm-hmm. And I appreciate that, Dirk. I'm going to look at that a lot more than I probably do now. I know that a lot of times those replacements, because the structural stuff is usually staying in there, but it is important. And again, when we talk about interior renovations and why not use lower carbon things, some of these replacement lives can be really important to think about. And if it's just an interior renovation, you're really going to run sort of option A versus B, and the amount of embodied energy, considering that this will be replaced in a much shorter time frame, becomes really important. So I'll certainly look at that more than I do on some of the
other place
grab LCAs that I do.
That it can come in is when you're looking at kind of, it could require you to have a whole extra round of enclosure, like an extra roof that you may or may not need. That may or may not be accurate, say.
Right.
So that's a piece that can help if you're trying to get a sense of the relative impacts of the assemblies.
Yeah. Okay. Martine, what do you think? If there are no questions in the chat, or if anybody wants to yell out, feel free, or tell me I'm wrong about something, or please correct me. Please do.
I have a quick question, Tom and everybody. Hi, Jen Krieger. So this was awesome. I got to play in a world that I don't live in anymore. I don't spend my day-to-day modeling at this point. I spend more of my day-to-day trying to translate this technical information into non-technical language for, building owners, policymakers, department heads, things like that. So my question is, for those of you who have experience doing this, what are the crucial nuggets that you take from this end report, and how do you convey that to your clients or to the decision makers, and how do you zero in on what you want them to be most concerned about, or do you get that luxury?
You go ahead, Tom.
Yeah, I won't have a great answer. So Martine, you can follow it up and kind of knock it out of the park. But I don't know, Jen, that's a good question. I mean, we are trying to push this idea internally more and more to get more people talking about it on our end as architects. so that it starts to seep out into owner conversations. We want the design teams to think about cladding choices through a lens of embodied, which doesn't always happen. And we want to open our designers up to asking the question of structural engineers on the internal team of how can we do this better? What can we do? So we're just trying to get them to start to ask those questions. It would be cool if more people started to use Tally, although, you know, I like to hold it to sort of keep a job, but it's okay. If more people wanted to use it, that would be great for our firm, but more like getting people to ask the question. I think for us, we try as sort of a little strike force of sustainability people in our firm of like 600 or something. We're like the lone 6 people trying to do some of this stuff. We try to do quick studies, just like, you know, I mean, literally, I think this comparison of structure and cladding at a schematic level did go into a diagram that went into a sort of small section of sustainability where we went out to a client and talked to them about. So, you know, I think the nuggets for us are trying to look at carbon intensity of our buildings more and more, to sort of say literally what is the pounds per square foot. And so I realize I don't even know if people can fully see all this, but trying to do some of this math on the back end to get some graphics like this to come out there a little bit more. And you know, I'm willing to talk with anyone about this and what the suggestions are, but at the end of the day, we're kind of tugging at heartstrings. There is lead. I mean, I'm sure a lot of us do that anyway, but the lead credits are a big part of it, right? We will use lead as kind of a, you know, and AAGB discussions as well with embodied, however we can do it to sort of bring it up in some kind of kickoff. You know, we want sustainability to be the number one thing in the design charrette. But usually the number one thing in the design charrette is money. And then the number 2 thing is like, where's the transformer going to go? We want it to all be sustainability all the time. We don't always get that. Sometimes we get 2 slides about lead, but using that credit is a way to sort of push that and say, we think we can get two credits there. It's going to involve working with the structural engineer. It's going to involve this. And then, you know, a month later, when we do a schematic presentation, literally pulling and I don't want to give short shrift to like eutrophication and some of the other terrible things that happen in this world every time we build a massive building, but we're usually looking at some global warming potential and just doing those comparisons of sort of choice A and choice B, trying to get that information somewhere in a PDF to push it out there, and trying to get the designers more and more to understand their ramifications in those choices. You know, if you move a column in, you know, 5 feet so that you can get people closer to the window, great, client's happy. Well, I'm sitting in the room like, wait a minute, your slab just went from 4.5 inches thick to 8 inches thick. And that has literally jumped us up, you know, millions of kilograms CO2 over the 7 stories of this building, you know. So I don't know if that's kind of a good answer or even close, but that's what we're trying to do.
Yeah, I think within designers, it's about highlighting kind of the relative impacts from different assemblies. So where's it like from the foundation, from the floor, from the column, from whatever, and then also the different materials that you're using with like concrete, steel, your enclosure. But yeah, I think the kind of broader conversation, especially with owners, is really just how we think about building sustainability. Because I think if you ask most people, they'll say like, what do you think when you think building sustainability? And it's okay, like solar panels, like plants, all of it's operational, like reclaimed water maybe, but I don't think very many people think of like the building materials themselves. And even in the building industry, this has been a small part of the conversation. Even now it is, but it's growing. So getting people to understand like these are complicated things, but materials matter, and it matters up front. And using less is more basically. And just kind of that framing, not even just in the context of building, but like just the idea of stepping away from consumption. And that's, I mean, I don't need to go on a political rant, but
oh, and Martine, you need to talk about Athena. One last thing. Can y'all see this? The greenhouse gas equivalences. Has anyone ever?
Yeah.
This is another thing I play with too. So if you just look at, you know, if you have emissions data and we'll say, metric tons, and you just say like whatever. You could put in the metric tons and it'll show you like stuff that you've saved. So sometimes I will use this. I'll be like, your building is so bad, it's like 2 million pounds of coal.
That's okay. Sorry. Look,
so what I'll do is like, I'll take, I do this, I do a lot of dumb infographic stuff. Like I'll take this number, like this difference, like that 1 million or whatever, and I'll throw it into that. Oh, my calculator's on the other screen. I'll throw it into this, and I'll just say like, it's this many passenger vehicles driven sometimes. And like, I've always had a dream of doing a presentation where I like get an infographic for every single car, and then just like flip page after page of like the hundreds of millions of cars that are like being saved between like choosing between CLT steel hybrid structure and the concrete 8-inch slab, whatever you're trying to build. So anyway, I don't know, stuff like that.
And yeah, I'll add one thing to that. And this is for anybody, but when we talk, and I know I need to talk about Athena, but it's a lot simpler than it's free, but it's kind of boxy. It's fine. We'll talk about Athena. But when in the context of buildings, when we talk about, we saved this much carbon, we saved this much, you're not saving carbon. You are spending carbon. If your building does not take any energy, but you build it, you are spending carbon. If I say last year I saved $20,000 on handbags, but I spent $80,000 and they were all 20% off, I didn't save money. I spent a lot of money. And so what we need to do is we need to start saving that money. And that's where I think embodied carbon comes into the conversation. Is no matter how green a new building is, it is still a new building. You're still spending a lot of carbon. And I think that's what people should understand is when we look at new construction, embodied, and we look at these timelines, embodied carbon is a huge chunk of the pie. So we can't, and this is just a whole big problem I have with greenwashing in the building industry, and that's a separate rant. But thinking about the idea of saving carbon versus spending carbon, because it really is just spending carbon.
This is certainly sort of a less bad thing, right? This is not regenerative design. We're not there yet. I'm going to hell. I just hope that it's the third circle or whatever, not all the way down with Dante. Like I'm hoping that by trying and educating, I can stay somewhere at the higher level, but I think that's a great point. And the other thing too, that I'm really obsessed with, and it's very complicated, is like, how much does your building weigh? How do we make it lighter? Well, there are a lot of things that we add on too for operational use, which we're not looking at the embodied impact on. And I won't go into my rant about shades, where people are like, yeah, we're shading the windows, or putting aluminum shades on the windows. And I'm like, but the embodied output for making fresh aluminum shades is not like the operational energy to cool your building. Like the payback period is like 60 years for those shades to make up the operational from like just not having them, if you just decrease your window to wall ratio. So I'm really hoping that in my career more and more I can like start to, because we get honeybee and we do all this super cool stuff on the operational side, but how can like we get more facile at the embodied side to say, hey, but if you make that decision, the payback period doesn't make sense, because the output in embodied CO2 versus what ERCOT's going to give you over the next 30 years of your operational, it's like, don't put shades on, just get Meco shades and take a couple windows out, or like make your solar heat gain coefficient 0.25 instead of 0.35, and you'll save all that stuff that you're trying to tack on. So, and that comes up a lot. Like obviously we think about shading a lot because it's Texas and it's just as hot as the sun, but like there are other things that we do as architects that I would like to get a better handle on, about how operational really matters in the life cycle versus embodied. Still less bad, but we're trying.
Yeah.
Thank you. That's super helpful. I will let you get to Athena, but I want to ask one last question. You can type it in the chat if you want. But does anybody ever ask about sulfur dioxide or smog or the eutrophication component? Like, does that ever come up? Or is that just a fun toy?
Not independently.
See, I took a drink right when I had to answer that one, Martine. See my move? No, It does not come up very often for me. I mean, it comes up in discussions with EPDs, obviously, and in the lead credits, the lead credit looks at least 3, I want to say, of the impact categories. So you can't get worse. You can't get like really good in global warming potential, but get worse in other categories. Like you have to make those percentages correct across the board. But I will say, as much as just having sort of an ecology hodgepodge background that I have, it's stuff I think about, right? Like, I mean, I think about ocean acidification. I lose sleep over it. But my working life is like CO2 bad, how do we just, well, and now methane bad too. People are like natural gas, and like there's nothing natural about natural gas, but that's another thing we'll talk about later. But really, it's looking at global warming potential, I'd say, in a professional setting and LCAs usually.
And I think the regional relevance of those different impact categories, it varies a lot. And so I think as we get more into like the complications of LCA, like what if this was more regionally specific on which ones matter more and how it's weighted? That I think is a great next step, but that we're not quite there yet. And okay, so I'm gonna do my best to fly through Athena. I'll try to keep it under time, but sorry if it goes over. If it does go over and you have to leave, we're still recording it, and I can keep talking to an empty room just fine. Okay, during your presentation, I realized there were a couple other slides that I didn't go over that I wanted to, so I'm going to do that. Let's present. And so Tom and I both put together kind of like PDFs of these instructions that we'll share with everybody afterwards. And so we'll have the recording, you'll have the PDF, we'll have all these reference materials. And these are living, I added this little thing. These are living documents. We can change them, tell us what else we need to know, and we can update them. But so we're not talking about one-click LCA today. That's because I haven't used it, nor has Tom, and we have limited time, but it's another LCA software. But the main difference is, so they use different data sources. Athena is free. Tally costs $700 a year, and then you also have to have Revit. Tally also gives you a lot prettier reports and a lot more flexibility. Because Athena is free, they just don't have the same time to work on it. And then the kind of sort of the system boundaries that we're talking about and how the operational stuff is included. So I mentioned how EPDs have a shorter scope. So that's here in the product stage. This is module A, module B, module C, and then module D. So this is where EPDs live. And then when we look at a whole LCA, it's like A1 to A5, and then B, and then C. It doesn't include operational energy or water use, but when Tom was showing how you can input that into Tally, that's where it's included in B6. So I'm going to give a kind of a brief overview of Athena, and then I'll open the software and we can dig in. But I think this is what I'm going to share with everybody in the PDF. But I just want to show, so the inputs, you have your building information. So where is it? The building life expectancy, occupancy type, all that information. You have operational energy, your assembly information, so all the geometry, and the material takeoffs. So you directly put this in. This is not integrated within Revit. And you input those into different assemblies. You split them up into extra materials, however you need. And then it goes into the back end. Athena does its thing and runs those impact values to it. And then it outputs different reports for all these different impact categories. And then you're able to sort through that. You can do comparative analysis. You can have your bill of materials. And how much more of this do I need to show? I'll just go straight into Athena with that. So here it is. Isn't it beautiful? So there's nothing open right now. And again, this doesn't connect to any BIM model or anything, but I just want to kind of go through creating a project, putting in the information, and a couple of different ways that Athena lets you do that. So create a new project. Right up here, you can do File New or click the New button. And then the first dialog box is the building information. This is Martine's building. Athena, so the project location, this helps calculate the energy information and also transportation distances, but it's also limited. So like Austin's not here. I think the closest is Atlanta. And then your building type, this helps understand, this informs if it's a leased building versus an owned building. It affects how the assumptions around maintenance and reuse. And then building life expectancy. So this is affecting, so in in Tally, where you can adjust the building lifespan for each material. In Athena, that's baked in, but you can still change the building life expectancy. And then my building height, gross floor area, let's say it's 3 by 3 bays, project number, whatever. And then, so this information is just for you, but you can also put in operating energy consumption. So it gives us these different ideas or different options for electricity, natural gas, and then it lets you compute it based off of a unit of energy. And this is all per year, but I mean, you put in, and I'm going to put in a lot of dummy values that don't make any sense. And that's just to keep it moving along. So that's all the kind of basic project information. And so the building height and the gross floor area, that informs some of the kind of preset assemblies that Athena has. And I'll show what I mean by that. So once I click OK, it creates it. We see Martine's building. And then I want to start adding to it. And so there are different assemblies. And so we know, so if I say add assembly, so foundations, walls, columns, beams, roof, that's a different way that Athena is just splitting up these materials and splitting up the impacts. And within each of those, it gives you the option to kind of have a boilerplate input. So for example, if I want to add a concrete footing, I click on that and it, let's say it's 5 by 5 by 3. It's telling you the units here. And if you want to switch to SI, you can. But it's giving me these, like the option for concrete. I'll talk about user-defined concrete later. There's a place where you can add in your own defined concrete. But it just kind of gives you this stuff in a box. Personally, I don't really like using it this way. I prefer to have more control of my quantity outside of Athena. I don't want to have to go in here and rebuild my whole building. But that being said, sometimes that works. And sometimes if you want to do a quick takeoff and it's easier to just use what's within Athena, then that's the best way. And I'm also 90% sure Athena is going to like crash on me while I'm doing this, because that's generally how these things go when you're presenting. So I'm just kind of hoping for the best, but I'm going to let it do its thing. And so the other way that you can do things is it has the preset assemblies for, I can actually show you how it's split up while this loads. Still loading. Oh goodness. There we go. So yeah, so it added it. So we see foundations, it's added, it's made those calculations, and we can open it there. The other way to add stuff, so we can see for wall, you can add your custom wall, columns and beams, metal building system. It has all these preset modules, but I can also just add, like for columns and beams, extra material. And what that does is I can just choose from Athena's whole library of materials. It's split up into different types. So you see aggregate, binder, cladding, etc. Or if I don't want to, I can just look at literally everything that Athena has. So that's all the materials, and I can select any one of them. Let's go ahead and do concrete, and then I add the material. If I want to add all of the materials from a particular, like, there's going to be some of all of the binders, let's say, because that's, or all of the concrete additives, because there aren't very many. I can just click add all, and then it adds all of them really easily. Athena does get really glitchy. If you have if any of these are 0, it freaks out. So make sure that none of those are 0. But the two ways, so you have your material input, the amount that you put in. There are 2 ways that Athena adds to that. The first is construction waste factor, which is set. You cannot edit that. The second is based off of the service life. And the service life is also baked into the material. And so I add in my amounts. There's 10 of each of these, and it gives you your units here. And units, I mean, you can go between SI and imperial, but that doesn't change. Then I click OK, and then it's going to take a bit of time to load everything up. And I guess while it's loading, I'll just give it a second. And so generally what happens is, because this isn't directly connected to your BIM model, whereas in Tally, you're saying, okay, I have it already defined. In this, generally what you do is you'd have it kind of, you might have your information in Revit. You could do a material takeoff, but you do your quantities elsewhere outside of Athena, and then you're able to kind of plug them in. And so the 2 ways that I've shown, you have the preset assemblies, you have add extra material. The other thing you can do is you can do a bill of materials upload. And I'm gonna go through a couple of the things here, and I'll show that at the end. But that is my favorite way of using Athena. But once I have, so we create a project, we defined building information, we added operational energy, we added a material. Oh, and you can also, to go back here, you can search. So if I know I have a 1/2 inch, I know that gypsum looks like that. So I could just put the 1/2 and it shows me everything that's 1/2. That's another way you can search for materials. And so that's adding materials. I mentioned the custom concrete. So if I go to tools here at the top, user defined concrete mix design library. And so I tested a mix earlier today. That's Martine's new test mix. I'm gonna add a new one. That's Martine's super new test mix. And basically what it does is you have kind of these different ways of inputting the components of concrete. And so I want imperial units. And so down here, so it has the plant process in there and that sort of stays. But I add components and it takes me to this dialog box where it's the same thing that we saw before. It has the material type, it has the materials, and you can sort through all of these and add whatever you want to the concrete. And I'm not going to create a whole mix, but if we add, what do we want to add? Some Portland cement, and then we're going to add water, and that's all it's going to be. That's our entire mix. But then you have your component material contribution types. So by unit quantity, so if I can say it's 2 parts cement to 1 part water, it makes those calculations for me. I can go by percent weight if I know that, or percent volume if I know that, whatever's easiest. But then I click OK, and so I have Martine's new and Martine's super new test mix. And then when if I want to add materials under concrete, I see all of, and these are baked into Athena, and these are the NRMCA averages, but I see Martine's new test mix and Martine's super new test mix. So those show up once you create them. So it's nice to sort of be able to build up your library like that. And then, and you can add it just like any other mix, and it already understands the components of it. If I'm doing a comparison, let's say I have something that's really similar to Martine's building, I can duplicate, which is a really nice feature. So, and then it creates a copy of Martine's building. And if I want to go back and edit, like let's say this is, I go back and modify, it takes me back to that first screen. So that's Control-click modifier, right-click modifier, Control-M. But this isn't a copy of Martine's building. It is Tom's building, and it's taller than Martine's building, and that's the only difference. Then it makes that change, and it's refreshing all the assembly information because, and maybe I shouldn't have actually changed anything because this might take a second, or maybe 43 seconds. But it makes it easy if you're making some comparison. You build one building out, and then you just copy everything over. And once this is finished, I can also show you within each material or within each assembly. If you just want to copy an assembly over to a different project, you can do that as well. But I'm going to wait for it to load because I don't want to freak it out. In the meantime, I can, so for the bill of materials import, basically what it does is it takes an Excel spreadsheet that you have, and if you have it mapped kind of the right way that Athena likes it, then it makes it really easy to just have your materials defined outside of Athena and then easily import them. And I have gone through the trouble of creating a spreadsheet that makes this super easy. And I'll share this with everybody. But basically what Athena wants for its bill of materials import, it wants your material name, it wants a quantity, it wants your unit of measure, and it wants your material contribution type. This is all way easier if what you have predefined is what Athena has. And sorry to interrupt myself. So yeah, there we have Tom's building, and it has these other components. And I mentioned copying materials. So if I want to copy just this guy, copy to project, Tom's building. If I want to copy, say where there were more foundation materials, I can right click on foundation, copy to project, Tom's building, and it would copy that whole foundation assembly to the other one. So that's what I do with 2 different buildings. If I want to do a bill of materials import, let's create another building. It's going to be Jen's building. And any of all that information is fine. So I right click, and I could do this for the other ones too, but at the very bottom of the dialog box, it's BOM file import. So there's bill of materials file import. And the Excel sheet has to be closed when you do this. So I'm gonna show you what's going on here, but this is basically like how Athena has defined these materials. So I pulled all of the materials out of Athena and said, these are all the aggregates, these are all the binders, and this is the construction waste factor, this is the lifespan, this is the units that they're in. And so what it does is when you're doing your material takeoff outside of Athena, this is gonna make it really easy for you to understand like what units do I need to put this in? What is the construction waste factor? What are these assumptions that are happening? And you can change, so the service life factor is how much is increasing. Like my building life is 60 years, this material life is 45 years, so it's going to multiply by 1.33, 60 over 45. But this is all going to update for you live. So if this is, we can see that organic felt shingles that have a 30-year lifespan, that funnily enough have a 25-year life. It comes in hundreds of square feet. That's the unit that Athena likes. But if I change this to concrete, it updates. So now it's cubic yards. I know that needs to be cubic yards. So I'm going to close this. And when I go to so again, right click, bill of materials, file import, I browse, I select my Athena, that's the sheet, then I load it up. And what it does is it just pulls in all that information, and then it has these different dialogues that you go, or boxes that you go through. So the first one is loading the file. And you can see the status flag. If there's an X, that means it doesn't know what to do with that information. Now in my Excel sheet, there was those couple lines at the top that just had instructions. And that's just so it's easier to continue living on beyond this call. And that's why this is all empty. And so you can see the skip flag says, skip this, I don't care about this. And here it's kind of finding some data. This is where the building life 60 years. It doesn't need to find that. All it needs to find is you can see this is identified as a header. So this is all the headers of my columns, and then this is data. And that's what we need. So we can see we have all checks. That's good. Next, we want to map the columns. And the reason that it's good to use this spreadsheet is the way that these can be defined. There are four things that we want. We want material name, quantity, unit of measure, and material contribution type. And because I've labeled my column heads accordingly, it knows that material type, that was just for my spreadsheet. That's just what I'm using. So that's not mapped. Material name, quantity, unit of measure, material contribution type. And that's looking at like floors, columns, beams, whatever. But this was all kind of the construction waste factor that I was doing just for my own information. That doesn't need to be mapped. I don't need to include that. And so this is green. I can move on. And then when I map the rows, so I know where the columns are, map the rows, what you really want to look is at the material name. Is it interpreting the right thing? And because I pulled those names straight from Athena, it should be a one-to-one match. So everything's checked. Concrete benchmark, 4,000, 4,000, 5,000, 5,000. All of these are the same. And if they're not, then you go in here and you put in the right one, and then it'll correct it. Then I check my material contribution types. And so over here, I see floor, columns, beams, wall, roof. Everything matched. It worked. We did it. And then summary, if I click OK, then it's going to run everything. I'm worried that's going to take too long, so I'm not going to do it. But basically what it does is it takes all that information and just floods it and puts it in accordingly. I'm going to go ahead and cancel. But then so that's the bill of materials import. Again, that's my favorite way to do it. I think it gives you the most flexibility and the most understanding of what your materials are doing, how to input them, and it's not hiding behind these different preset assemblies. So when I look at the actual output, I click reports up here, or you can click on one of the buildings and say reports. And I have 3 different tabs. So project reports, I select which building I want. It's not showing Jen's building because it doesn't have any material. But you can have tables, you can have graphs. They're not as pretty. Ooh. Am I back yet?
Martin.
Can you hear me now?
Yeah, you're back.
Okay.
Yeah,
that was on my
end.
end.
Lost
Sorry
your
about
screen
that.
share.
Okay.
Lost your screen share. No problem.
Everything good?
Yeah.
Cool. Yeah, so for project reports, you select your project, and I can show you some of these outputs. So the detailed LCA result versus condensed, that just means it includes every like A1, A2, A3 rather than like A1 to A3. So we can look at condensed first, and where this is a table, and this is by life cycle stage. So show me the reports. And so, yeah, so like I said, this is condensed. So it shows more broad, like A1 to A3, that's your total, A4 and A5, that's your total. And this table you can export, and it looks just like this when you export it to Excel or export it to, and for that, you'd click this button here, export Excel, PDF, Word, however you want it. If we look at the detailed LCA results, show reports, then it's pretty much the same thing, but you can see product is just one number here, and then product it shows manufacturing and transport separately. So it just gives you a bit more detail. And then of course it has the LCA measures on the left, and then total A to C and A to D on the right. And for the graphs that it shows, I prefer to kind of generate my own graphs from that, depending on what I'm interested in. Because it only shows the graph for the sorry, for the project comparison and the rating system reports. Sorry about that. It can also show me, oh, I haven't input. I don't know why it's not letting me, oh, because it wants me to do a table. So the other way that I can split it up is by assembly, group, embodied effects. So that was by life cycle stage. So we saw A1, A2, A3. If I do it by assembly group, it shows total impacts by foundations, walls, columns, beams, etc. And so this is where, again, it kind of falls short of Tally, where Tally gives you a lot more granularity in how you can split it up. Athena doesn't quite offer that. But then we can, okay, so we can do project comparisons as well. So Martine's building, Tom's building. Let's just, we're not gonna do all the measures because we're just gonna do a GWP and acidification. Otherwise it's gonna take longer to produce all the graphs. But if I want absolute value, I want it by life cycle stage, show reports. So it's going to print out different, like it printed one for global warming, one for acidification. So if I checked all of these, it would have printed out all of those reports. But I did it by life cycle stage. So what it's going to show me here is there's Martine's building, there's time, they're the same because I built them together, but it shows where these impacts are coming from. And if I do it by assembly group, then it produces the same two, one for global warming, one for acidification, but it does it by foundations, walls, columns, beams. And so this, I think, is a really valuable tool, especially early on when you're trying to inform what am I going to do? What am I going to change? This gives you that idea. And it also gives the numbers here below. And that's just the total values that we could have gotten before as well. And like Tom had kind of shown how he likes to pull it and into his own spreadsheet and do it, I like to do the same thing with those a little bit more detailed tables that it shows. But what it also does is, if we want, I've never used green globes, but for lead, it can produce a rating system report, and the information is there beforehand, and you could put it together yourself, but this just puts it together the same way that lead might want to see. And so here's just a project report. Here's a comparison. So it shows us all the different impact factors and then the percent differences. And this is how lead wants you to report it. It kind of asks for the total values and the percent difference. And so if you want that level of granularity, or sorry, if you want that convenience for specifically something like lead, then it's there. And that's, I guess, it for the reports. And like I said, you export those to PDF or you export them to Excel or Word as you need to. And bill of materials, of course. So this is for Martine's building. I can get a bill of materials report where it shows me, this is kind of the unit that it was input, and this is the total quantity, but then it shows the distribution between these different categories. And then it also shows everything in tons. So kind of this column and this column, that's this total quantity in that unit. And then this is oh, and then it shows you the mass value in tons. There it is. So that's the tonnage, and this is all in those units. So it still gives you the flexibility to do an LCA. You can still do everything, or not everything you can do in Tally, but you can still go through the whole building LCA process in Athena. It's not connected to your BIM model. The output is a bit clunkier. It's a bit slower, not quite as clean, but it's also free. So especially if you're just looking to dip your toe in the water and start exploring with LCA, it's a good first step. And like I said, we kind of put together these PDFs that we'll share with everybody. And so if you don't want to rewatch the video, you can just reference the PDF. And I'll also send this, here, let me open the spreadsheet again, because I want to, this is all my test, all of my tests. So these are, so I can select my, whatever section it is, it's roofing. So then here, it lets me pick, and I know this is a material within Tally, and then it shows me that information. I also put in a unit converter in here. I know this stuff is pretty simple, but I know it's the way Tally deals, or Athena deals with some materials, especially wood, is a bit complicated, and that's sort of outlined here. And then here's the whole material library if you want to reference it. And I like seeing these things outside of Tally, kind of behind all these clicks. So I find something like this really useful. I hope you do too. But with 1 minute overtime, that's about all I had. Happy to take questions, happy to stay on if people need. But otherwise, thanks everybody so much for joining. We really appreciate it.
Hey, Martine.
Yeah.
I did have one question. I know we're 1 minute over. Really quick, on the quantities in, I guess in the Tally world, the way I think about it is a lot of just like singular quantities. You know, you have this many, this, and sort of, since it maps by material, it's sort of selecting these things in your model and saying this one thing is this. In Athena, do you how did the quantities work again? Sorry, like if you have, you know, you have 7 piers, was it just by you know, or a certain amount of footings? Was it all by square foot? Would you sort of take all that and then say it's this many square foot total, or was there like a number of, say, you know, it's a 5 by 5 and it's 2 feet deep or something, and there are 10 of them, or do you do that math on your own? Or I couldn't remember.
Yeah, so it doesn't have a count. You can't add like 5 by 5 by 36 and there are 10 of them. So I would just put like 50. And so that's another reason why I just prefer to have it separate. I prefer to do the bill of materials import, but I understand why this might be more valuable to people. And so it's just two different ways to do it.
Is it the same in bill of materials? Is it that same way where it wants sort of the whole, you know, like it wants every slab all put together? So instead of, you know, 100 square feet, if you have 5 floors, it's 500 square feet. Is that the same in that bill of materials upload?
So if I want to add, like, let's say, here I can, so in this preset assembly, if I use user defined concrete, I can see my mixes here. So let's say I'm using Martine's new test mix. I shouldn't have clicked OK.
But it's still going to be a mix for like a 5 by 5.
So you just put in
area.
like concrete is going to be in cubic yards. So I just input cubic yards. I don't put in like 5 by 5 by 3. It's just straight up whatever. So add assembly, extra material, concrete, Martine's new test mix, and then so I input my cubic yardage, and so you make that calculation yourself.
You think in cubic yards a lot. I don't think in cubic yards that much. See, that's an architect. I'm like, I don't know how much they're going to pour. A ton of it. Like I don't. But it's good. It's good to see how you're doing quantities versus sort of the tally of identifying per material, and you know, obviously much more Revit based. So, okay.
So if I'm starting from a Revit model, basically what I do is I do like the material takeoff within Revit, and then I assign all those materials and say, oh, this is this strength. Sum them, get my values,
Yeah.
And then I kind of put them into this spreadsheet and then import them into Tally or import them into
Yeah,
Athena.
that's probably a good method actually of if you could schedule that out, you could kind of go from one to the other if you wanted to run it that way. So starting and getting all of that material from Revit and putting it in here, that makes sense.
Yeah.
Cool.
Any other questions, comments, concerns, thoughts, trials, tribulations?
The road warriors sticking with us this whole time. We appreciate
Yeah.
it. We're
didn't
always
go that
like,
much
don't,
over.
we'll get through this. This will be so fast. And then we get into it. And we're like, oh yeah, I forgot. You click that button and then this whole thing happens.